That aims to teach the clinical skill of retinoscopy and the application of it in ophthalmic practice. Retinoscopy is a technique that is utilized to obtain an objective measurement of an individual's refractive state. It is widely used in young and nonverbal individuals as it does not require any subjective input from the patient. During this clinical test, patients are conventionally cyclopleged, as this allows a clear streak to be visualized. So when do we use retinoscopy? Retinoscopy can be used in all patients because the test does not require any communication, intelligence, or visual acuity levels. They are often used in children, special needs, or any patient where communication is difficult. There are 3 different methods of retinoscopy. The first method is using a trial frame with a working lens inserted. The second method is using a retinoscopy rack without a working lens. And the third method is using loose lenses without a working lens. This video will focus on using single lenses. This is because it prevents the discomfort of the trial frame on the patient, and it also allows the examiner to quickly change the lenses during an assessment. To perform retinoscopy, the equipment required include the lens trial box and the retinoscope. The retinoscope is composed of several elements. These include the on button. To turn the retinoscope on, simply hold onto the green button and rotate. This then produces a light that looks just like that. The other parts of the retinoscope include the forehead rest, the peephole, which the examiner looks through, the cross-linear polarization filter, which needs to be down during testing, and the focusing sleeve. Raising or lowering the sleeve changes the focusing power of the beam, while turning the sleeve rotates the reflection. This is our patient Ahelia. Move the streak horizontally and then move the streak vertically. The streak that is produced from the horizontal movement depicts the 180-degree axis, and the streak that is produced from the vertical movement depicts the 90-degree axis. If the streak moves with the reflex from the retinoscope, this demonstrates a with movement. If the streak moves opposite to the reflection, this then demonstrates an against movement. When initially beginning the clinical test, it is recommended to begin with a with movement, as this is easier to achieve neutralization. In our patient Ahelia, she demonstrates an against movement. In order to achieve a with movement, the application of a minus lens is required. With the use of the -2 lens, Ahelia still demonstrates an against movement. Hence, the minus power needs to increase in order to achieve a with movement. As now with the -4 lens, we can see that a with movement is being demonstrated. So, how do we know if neutralization has been achieved? The streak should demonstrate several characteristics. Firstly, if the streak is close to neutralization, the streak should be brighter, faster, and wider. Once neutralized, an on-off phenomenon should be seen, where the pupil fully lights up. As previously seen in our patient Ahelia, a with movement was achieved with a -4 lens, but the reflex was narrow, dull, and slow. Therefore, we need to decrease the minus power to achieve neutralization. Conventionally, we work in 0.25 increments, but this depends on the characteristics of the reflex. For example, moving from -4 to -3.75, the reflex becomes faster, but it is still very slow. Therefore, we need to move in increments more than 0.25. So now we add the lens power of -2.75 to quicken the assessment. And at the minus 2.75 lens power, it is very close to neutralization, but it is not yet neutralized. Now we add the minus 2.5 lens, and we can see the reflex is faster, it's brighter and wider, and the on-off phenomenon is observed. To confirm that neutralization was achieved, move down to minus 2.25 and then against movement should be observed. This technique is now repeated on the 90-degree axis, and the minus 2 dioptric lens power achieved neutralization. If the reflex is tilted, this indicates the axis is oblique. Therefore, rotate the retinoscope sleeve so you can straddle this streak appropriately.
For the recording, you must write down the gross ret and the net ret. Gross ret being the cross diagram and net ret being the overall equation. For our patient Ahalia, we observed neutralization with a minus 3 diopter sphere lens at the 90 axis and a minus 2.5 diopter sphere lens at the 180 axis. This is our gross ret. In order to calculate our net ret, we must start by calculating our working length. You can do this by dividing 1 by your working distance. The distance between my and Ahalia's eye was 0.6 of a meter, which is equivalent to 2/3. This is my working distance. Not all working distances will be the same, so it is important to measure this accurately. So 1 divided by 2/3 is equal to 3/2, or 1.5. If a psychoplegic agent is used, you have to compensate for this by adding it to your working length. 1 for atropine and 0.5 for psychopentalate. We use atropine, so we're going to add 1 to our working length. That gives us 2.5. We have all the information we need for step 3, so now comes the fun part. You can decide if you want to work in minus lenses or plus lenses. For our example, we're going to work in minus lenses, and by working in minus lenses, we have to take the higher number and minus our working lens and atropine to get our spherical component. Minus 3 might be the bigger number, however minus 2.5 is a higher number as it's closer to 0. Therefore, our equation would be minus 2.5 minus 2.5, which equals minus 5. As for our cylindrical component, you have to determine the value needed to get from the higher number to the lower number. So the number needed to get from minus 2.5 to minus 3 is 0.5. This will be our cylinder. We will also use the 180 axis as we are working with the minus 2.5. So putting it all together, our net ret will be minus 5 diopter sphere with a minus 0.5 diopter cylinder at 180 degree axis.
These include the on button. To turn that retinoscope, it was already on! Of the streak is from the 100 degree